In this video, we'll be covering three main topics, the first of which is the move constructor and the move operator equal, and we'll see how they're different from the copy constructor and copy operator equal that we did last time. Second is templates and how we can basically modify our code to allow multiple different data types to perform the same function. And third is exception handling, why it's important, and how we can create our own exception classes that are dedicated for our own program. So what we're given is the int array class that we worked on last time that had the default, parameterized, and copy constructors, as well as the destructor and copy assignment operator. And the main idea of the last video was what the copy constructor does. And basically what it did was it makes a deep copy between the elements from the other array into the calling object. So both arrays will have the same elements, and similarly for the assignment operator. But now, when we move on to the move constructor, basically what the move constructor does is that instead of copying element by element, this can have a problem if, for example, the array had, let's say, 10,000 elements. This would use so much memory and it would take a very long time. So instead of copying element by element, we will just move the array from one place to another place. So basically, the array is moved from the other array into the calling object. So to have this as code, we will have int array, and what we do is instead of passing a constant, because we're now modifying the array, is that we will need it by reference. So the other, and we will add no except. That's what Visual Studio recommends. And then we said we want to move the elements from the other to the calling object. So what we do is that this array, this dot array, is equal to other dot array, as simple as that. And this dot size is equal to other dot size. And now we don't care about what the other element, what the other array has. So we just say other dot array equals null and other dot size equals 0. So we basically just get rid of the other array. And let's have a print saying that move constructor is called for size equals size. Okay, that's it. It's much simpler than copying element by element. So now we just moved the array from the other into the calling object. Now moving on to the move operator equal. So basically it will combine the logic of the assignment operator, the copy assignment operator, by having the same steps, which first you detect for self-assignment, but instead of doing the deep copy, you will do the shallow copy we were introduced to in the move constructor. So you will have int array, you will return by reference an operator equal, and you will pass it int array the same way as we did in the move constructor, right hand side, and add no except. Okay, so now let's visualize the logic for the move operator. So let's have an example where you have two boxes, one box for your left hand and one box for your right hand. And let's say you want to move the box from your right hand to your left. So the most basic steps is the first thing you do is you drop your left hand box. So now your left hand is empty. And then you move the box from your right hand and place it in your left. So now your right hand is empty, but your left hand will have the right hand box. So how we do this in code is first you delete this dot array. So you empty your left hand, and then you want to move the right hand box to your left hand. So this dot array is equal to right hand side dot array, and this dot size is equal to right hand side dot size. And now your right hand is empty at the end, so right hand side dot array equals null, and right hand side dot size equals 0. And then you return star this, the reference to the calling object. And to detect for self-assignment, basically, if right hand side, if this is not equal to right hand side, to the reference of right hand side, then you would perform the following. Then you will return a reference, and let's have a print move operator equal called for size equals size. Okay, and that's the move assignment operator. And for the next topic to discuss is templates. So what is a template? Basically, a template is a way to allow your program to have multiple data types performing the same function. So for example, if you have a function that has an integer as one of its parameters, but you want to call that same function using a double, instead of copying the function and creating a new one for a double, so having two different functions that have the exact same functionality, what you do is that you will have one generic function that takes a template. So once you specify that this function will take a template, then if you pass an integer, the function will deal with the integer accordingly, and the same thing for the double. So the function will know whether it will deal with an integer or double, and it will perform the same functionality. So to understand the topic more, let's have an example. So given the following code for a sorting function, fix the code to allow for multiple data types, or in general, just use templates. So basically, you want to allow an array to be either integer or double or float or whatever. So what to do is that you want to mention that it's a template, and then type name t. Now the type name is the, instead of integer, so you have the data type, it will be called t. And this could be, you can write anything, you can write template, but just keep t as simple as that. So let's see where else we can change the integer to a t or a template. So in this function, to enter number of items, there's nothing to change there. What about in the sort? So you have the array integer, this should be t. And it's very important to have the header before the function to know that, okay, I will deal with a template instead of a certain data type. Okay, and int index of next month. So this should stay as an integer because this is an index variable. And what about for swap? So where's the swap called? It's called here. So this value can either be an integer or a double. So this should be changed. So should this, and we must add the header. Okay, anything else in the function? Yes, integer temp, this should be t. Okay, and now for the last function, the array is a template. Okay, integer min, so this should be t as well. Okay, and that's, I believe, that's all the changes we need to do. Okay, now let's remove the comment because we will use these functions in the code. Okay, so now that we got the main idea of templates, let's change the entire class and let it be a generic class for any type of array. It could be integer, it could be double, it could be character, it could be anything. So what to do is basically we'll change the name, we'll just keep it as array. We'll have a lot of errors, but we will deal with them now. So first thing is add the template header. So now the program knows that, okay, this class can be changed based on whatever data type you want. So it will be array, and now instead of integer, because we mentioned the type name should be t, the template. And also let's put it before we start as the private attribute for the array. Okay, and now let's change this to also int array. This should be t, this should be array, this is t, this is int array, nothing to change here. This is int, this is just array, array, this is t, Okay, and one more change over here. Okay, that should be all changes. So now our array class, is a generic array class that can be used as either an integer or a double or whatever you want. So let's test this in the main. So let's have test one. So let's see out. Let's test. Okay, and one more function to add. We should add an function that returns an array. So let's have array. Also, we need the template first. Array, and then function that returns array. So all this function does is that we create an array of whatever, and let's call it array, and then just simply return array. And now there's this array here because we need to mention that this is a template array. And that's a simple, very simple template function. So let's test a1 equals, it should be a function. Okay, so let's create an array. So let's have the first example as an integer, and it's called a1. Let's say equals function that returns an array. So now there's an array here. It says no instance matches the argument. This is because we need to mention that this function should return a template. I mean integer, sorry. The template here should match the template here. That's very important. This should be just array1. Okay, like this. Okay, so now let's just run the code and see what happens exactly for the first test. Okay, so test one, move operator equal is called for size 5, and then the generated array will have the 5 elements, and then memory is destructed. Okay, so the move operator is called. So there's actually two reasons for this. First of all, because we have array1 equals, so the function that returns an array will return an int array, which is what a1 is, so and we have the operator equal. So we're basically moving this array into array1. And then you may ask, why is the copy operator not being used? And that's because we didn't mention that this is a constant. Because if you go back to the definition, so copy assignment operator would take a constant array, the constant reference of an array. So if I change this function to return a constant array, then it should call the assignment operator, the copy assignment operator, which it does here. And then it directly destructs the memory. So that's another reason for using a move operator equal. So instead of having these two steps performed sequentially, the move operator equal is being called, and it will not destruct memory because you're not creating memory. You're just moving the array from one place to another. Okay, so that is the first test. Now, let's see when the move constructor is called. So let's have the test2. Let's test, and let's say we have a vector, and we're gonna pass, we have a vector of array double, instead of integer. Let's see how that works. And then let's have pushback. Also array of double. And let's give it 10. Okay. Let me copy this. Okay. So what we're doing is we're creating a vector of type array, a double array called vector, called vec, and then we're pushing back or adding an array double given size 10. And then let's see what happens. So S2 move constructor is called for size 10. That's because when we call the array double of size 10, this will create an instance of an object. This will call the parameterized constructor. And then we say vector. So at index 1, it will be. So basically what happened is vector at index 0, you're passing it this array. So this is what happens behind the scenes, basically. And that's why the move constructor is called. So you're moving this array into the vector at the first index. I hope that is clear. Okay, now let's look at the demonstration of how the sort functions work. And so I copied this code to fill and sort a raw array. So basically we create a raw array, it could be type double, this could be integer, but for this example it's a double. Then you pass it to the fill array function, then you print the raw array before sorting, you pass it to the sort function, and then print it after sorting. So let's quickly see how this works. So let's enter 5 numbers, 10, 19, 22, 0, and 8. So it sorts it correctly. And because we did the template functions, so this code should also work for decimal numbers. So let's say 11.2, negative 19, 29.9, 12, 99.8, and 0. So as you can see, it works perfectly for both the integers and doubles, and it correctly sorts. So that's why templates are very useful, because the same function was used for 2 different array types. Now, the last topic is exception handling, which is actually one of, if not the most important topics in all of programming, because it kind of allows you to control how you want your program to run. So for example, if you have a certain block of code and halfway through there's some sort of runtime error that happens, and what the program does is, instead of acknowledging that there's an error here and continuing to run the other steps after, the program will stop, it will raise an error, and it will crash, which is not ideal. So what we can do is identify the certain situations in our code, because we know the program, so we can tell where a certain error might happen. And if we know that certain area, we can try to execute the code. And if anything goes wrong, so if an error is raised, then we know how to deal with that situation. So if you have, for example, a divide by 0 case, and you have a try-catch block, so you try to run that code, and if a divide by 0 error happens, then you can catch that error and print out, okay, what the program does is like, okay, here is a divide by 0 error, let me print out a certain message. And it will continue on with the other steps, because it's like, okay, I know that I have this certain error that happened, and because we informed the program that this error can happen, then it knows how to deal with that situation. So in our example for the array class, or dealing with any numbers, some of the most common errors, one is the divide by 0. Let's just have that on the side, so divide by 0. Another one is indexing out of range. So if you have an array of size 3 and you're indexing at 8 or at -5, then that's also an error that can happen. And then if you don't know any other errors on the spot, then you can just create a generic class that will deal with all other types of errors. That's usually called the exception class. So in our program, we can have 3 different cases for errors. So how can we deal with that? We create a class. So first we create the generic class called exception, and then the other 2 classes will inherit from that class. So basically here we have a protected, and it's called protected because it's inheritance, so the parent class must have protected instead of private. So let's have a string message, and for the methods, so public, and it will be default, lowercase, a default constructor where you pass the message is empty. Okay, and then we have a parameterized, so you pass it a string message, such that message is equal to message. And then, because we have inheritance, so we will use virtual string, and let's say get message, and it's constant, and we return message. So this is, in most cases, the most common generic exception class that's used. And then in our case, we have a class called divide by 0, and this will inherit from exception. Now, C++ or Visual Studio, it has its own generic exception class called exception as well, but it's in lowercase. So that's how we differentiate between our own created generic exception class and Visual Studio's one. Okay, so similarly, we have the constructors. So this one called the exception, and let's pass it to divide by 0 error, and parameterized string underscore message, and we pass exception with message. Okay, so that's the first class, and the second one will be, let's call it out of bounds. This also inherits from exception. And let me just copy this, make it faster. Out of bounds error. Okay, so now let's find in the code where we have to notify the program that, okay, if an error happens, then call this certain function. So let's create a function, first of all, let's get the divide by 0 case out. Now let's implement the safe divide function. So the function should return a double, and it will take in two integers, so int a and int b. And so what case will we have such that the exception is thrown? And that's if we're dividing a and b is a 0. So if b equals 0, then we have to throw an exception of type divide by 0, and we'll give it a message of cannot divide by 0. And then if b is not equal to 0, then we can do the normal division where we return a double of the integer division, a divided by b. Okay, and now for the other case of the out of bounds error. So that can only happen when we index the array, which is found in the operator, the square bracket operator function in the class. So the difference between the two classes is that between the two functions is that this function is called if constant is mentioned upon the array initialization. So if we have a constant array, then this function should be called. So if index is less than 0, or if the index is greater than or equal to the size of the array, then we are out of bounds of the array. So we will throw and we'll pass it the message index is out of bounds. And let's also give it a the index used by toString, And then if it's not in this index, then we can return the array element, and similarly for the other function. So now in the main, let's test out how these exceptions are called by creating an array. Let's make it of type integer, and let's call it array. And let's also pass it the size of number used. And let's create an integer called I for our loop, which is the size of the array. So while I is greater than or equal to -1, just for the sake of testing the errors. So let's try to divide. We'll store it in result. We'll use the function safe divide. We'll pass it the array at index I and 0 because we want the error to happen to see what happens. And then let's catch for the errors. So the first one is divide by 0. And let's print out that we have a divide by 0 exception. And let's also print the message from the class. So e.getMessage. And the same for the out of bounds class exception. So I'll just copy this. And out of bounds exception plus get message. So let's run the code. Okay, I forgot to add the I minus minus for the loop. So the code again, and it could be either integer or double, but I will keep it as integers with size 5. So 19, 8, 27, 10, 8. Okay, so at index 5, that's out of bounds because we have a size 5. So the out of bounds exception is called. And then for the indexes 0 to 4, we have the divide by 0 exception. Since the index is within bounds, but we're having that error. And then at -1, we're getting, again, the out of bounds error. So with this, hopefully you learned how to understand your code such that you know when an error is raised, and as such, you develop the code accordingly to deal with such errors and notify your program to have prior information of the situation that they have to deal with upon any runtime error.